So, imagine spending thousands on a massive, state-of-the-art 8K stadium display.
Oh yeah, that is a massive investment.
Right. You wire the whole thing up, you flip the switch for the big game, and, well, the screen just goes completely black.
An absolute nightmare scenario.
Exactly. So today's deep dive is into a piece of invisible infrastructure designed to make sure that absolute nightmare never happens. We're looking at like a masterclass in extreme AV engineering.
But completely disguised as a simple wire, right?
Yeah.
The DVIGear DVI-2890-AOC DisplayPort cable.
Yeah, that's the one. And our mission today is to uncover how this specific cord defies physics to send huge amounts of data over massive distances. So, okay, let's unpack this. Why on earth does this single cable cost $1,090?
Well, even with a 10% discount code, it is pretty steep.
I mean, I can go online right now and buy a really long DisplayPort cord for like $30.
You totally could, yeah.
Yeah.
But in a professional environment, you would just end up with that black screen you mentioned.
Right, because of the bandwidth.
Exactly. You have to understand the physics problem it's solving. Right. You aren't just buying copper wire here.
Right, the problem of distance. Because pushing 8K video at 30 hertz or 4K at 120 hertz, it requires this incredible 32.4 gigabits per second of bandwidth.
Which is a staggering amount of data to move.
It really is. It's like trying to blast a high-pressure fire hose of water through a mile-long cocktail straw, you know? The physical capacity just isn't there.
That is a great analogy. And we connect this to the bigger picture. The reason standard copper fails over a distance is just electrical resistance.
Right, the metal basically fights back.
Yeah, as an electrical signal travels down a copper wire, the metal naturally resists it. The longer the wire, the more that resistance builds up.
And that just smudges and degrades the data, right?
Exactly, until it's just useless noise. Now, this DVIGear cable is 100 meters long.
Wow, that's 328 feet. That's a literal football field.
Right, and over that distance, copper just completely loses the fight against resistance.
Okay, so here's where it gets really interesting. How does this cable maintain that massive fire hose of data over a football field if copper physically can't do it?
Well, by abandoning electricity for the heavy lifting.
Wait, really?
Yeah, it's an active optical cable, or an AOC.
Okay, so it uses light.
Yep, it has a hybrid design inside. It uses 4 glass optical fibers, which they call GOF, and those run right alongside 6 standard copper wires.
Oh, so it does still have some copper in it.
It does, yeah. Copper just handles the, low bandwidth control signals.
I hear.
But the heavy video data itself is actually shot down those glass fibers as literal light.
Wait, light. So instead of trying to push a heavy physical current of electricity down a wire, it's basically using microscopic flashlights to blink out Morse code at the speed of light.
Yeah, that is a really good way to look at it. Photons just don't experience electrical resistance the way electrons do in copper.
That makes perfect sense.
And what's fascinating here is that the cable has microscopic optical transmitters built right into the ends.
Like inside the plug itself?
Exactly. Using multi-mode lasers, actual tiny lasers built into a plug no bigger than your thumb, it converts the electrical signal from your source into pulses of light on the fly.
Hold on. Converting a massive electrical data stream into lasers usually requires, dedicated hardware.
Oh, absolutely it does.
You're telling me there's an entire media conversion facility inside a thumb-sized plug? Does it need its own power supply?
See, that is the most impressive part. No external power adapter is needed at all.
Seriously, where does it get the power?
It draws an ultra-low 0.43 watts of power directly from the DisplayPort source itself.
Wow, that is incredibly efficient.
It really is. And because the heavy video data is traveling as light rather than electricity, you get 0 electromagnetic interference.
Oh, right, because light isn't affected by magnetic field.
Exactly. It doesn't matter if it's snake past giant high-voltage stadio equipment, The light inside the cable is completely immune to outside electrical noise.
So what does this all mean for the people actually installing these things? Like, if you're an IT director wiring up a high-voltage stadium scoreboard, you must be pretty thrilled to not worry about interference.
Oh, absolutely. And the physical design caters entirely to those brutal installation environments.
Okay, how so?
First off, it's plenum rated, specifically UL-CMPOF.
Okay, jargon alert. What does UL-CMPOF actually mean for you and me?
Fair enough. It means critical safety. It's a strict fire code certification.
Ah, so it's about building safety.
Right. If you run this through the air spaces or drop ceilings of a commercial building and there's a fire, The cable's outer jacket is formulated so it won't burn and release toxic smoke into the building's ventilation system.
Got it. But honestly, snaking 100 meters of cord through tight commercial drop ceilings sounds like a complete nightmare.
It usually is.
Especially if the plugs at the ends have all those built-in lasers making them bulky, right?
Well, they actually solved that too.
Oh, really? How?
The ends are ultra-compact mini DisplayPort connectors.
Oh, so they're tiny.
Very tiny, making it incredibly easy to feed through tight conduits.
But wait, most big stadium screens don't use mini DisplayPort, do they?
No, they don't. But once it's successfully pulled through the wall, it comes with detachable, full-size DisplayPort docking connectors.
Oh, that's clever. So you just snap them on after the pull.
Yep. They snap onto the mini ends and secure with a locking pin so they never accidentally get yanked out.
Wow. It's wild to think about. When you really break it down, this isn't just a cable.
Not at all.
It is a 100-meter fiber optic data highway, completely disguised as a flexible, everyday AV cord, just working silently to keep high-end displays perfectly synced.
And this raises an important question for you to think about.
Oh, I like where this is going.
The next time you're standing in a stadium, looking at a massive, flawless display in a control room, take a moment to look past the glowing pixels.
Right, look at the infrastructure.
Exactly. We always marvel at the screens themselves. But what if the true marvel of the modern world is the invisible, microscopic pulses of light traveling hundreds of feet through the dark walls just to make those screens shine?
A football field of laser light blinking out data, all powered by a plug the size of your thumb. I know I'll never look at a giant display the same way again.